working on in a stealth startup. So while I cannot tell you everything that we do, I can give you 10 bits of something that I started to work when I trained Gemini 2 and Llama 3, and the stuff that we're pushing to the next level in our startup. So this is a joint work with some people that disappeared. I don't know why. With Annie and that week's for Mila, Joshua Bengio, who is his advisor, Sanjeev Arora from Princeton, Nan team from DeepMind, Danilo is also from DeepMind, Michael Moser from Google Brain. And so they, people say that what separates us from other animals is that we are thinking, right? And and here we'll show it how to put it on the next level, because humans are not only good about thinking, but we also have this so-called theory of mind. We are able to think about thinking, and more forward. And it was actually very relevant what we heard before, because in the past there was this Hilbert program of mathematics when they tried to have a categorized mathematics. So I don't think of AGI of something that will re-reach it or not, right? Because there are levels of thinking, and since as we read the Hilbert program of mathematics, right, axiom, first order logic, second order logic, we can be probably also having some Hilbert program of AI about thinking. Well then the Gödel was not very happy with his program because he tried to prove that God exists, and he got crazy. But let's not go there, and let's do something much more specific, something that that I already applied in several startups that I advise. And so this is actually how to actually retrieve better things from a memory and use it for better inference, right? So thinking about thinking. I didn't invent that. This is something that psychologists study for a long time. They call it metacognition. And metacognition is the knowledge about one's own cognitive processes, so thinking about thinking. And what we try to describe here is like, what is this and how to actually use it to train LLMs better. And first we need to actually understand, do actually large language model have this knowledge, right? So let's think about something simple that everybody can understand, because it's from the same field. We all had math. When we solve specific problem, either in industry or in math, we have some catalog of skills, right? Somebody is good at networking, somebody is good at math, and for each of the tasks we solve, we use multiple skills. For what is the common divisor, we use, addition, subtraction, ratio, and so on. But as the knowledge of LLMs are improving and the capabilities are getting higher, we will need to see how we actually express this metacognition knowledge as well. And so the simplest way, something that we can do humans, like, which skills did you use them? You can just ask LLM, which skills did you use to solve this problem? So for example, here's mathematical questions, car travels, blah, blah, blah. Which skills did you use, dear LLM? And LLM would reply, distance times calculation. These are other examples. You can do sum of two numbers. It's solving linear equations, and so on, so on. And here I'm with friends. We did these experiments with GPT-4 because Princeton had 80 million grant for GPT tokens that we use for this research. But it's not limited. Here I'm in France, and my students, that founded a company called Mistral, also, have a project called Mixtral, and they also is also able to retrieve some specific skills from LLMs. So, in next thing, we would like to be more quantitative, right, about this evidence, right? One thing is just asking, what skills do you use, but one is like to be more precise about that. So how do we do it specifically? The stuff that you use, and it was mentioned before, like typical example is ICL, in contextual learning, right? Like this is something that was discovered 4 years ago, and that started big wave of that ended up with ChatGPT. And so typical example, what people do in context learning, they ask several examples, like 2, 3 plus 3 is 5, second, third, and then they ask a more difficult question. Hopefully it will help LLM to solve it better. But right now we go for further, and the next example that people use is chain of thought. Roger Federer has 5 tennis balls. This is the answer. In chain of thought problem, we can do something better because we describe also the process that we use to solve this question, and we can get actually the right answer. But sometimes this retrieval of incognito example is not very good, right? That's sometimes you find out that your RAG fails and you don't get what you're looking for, right? And this is because the RAG or similar methods, embed your prompt and look for similar prompt. But let's say, my question is about physics or finance, and so most likely what I find is it will be examples from, let's say, physics or finance. But maybe, the best skill should I use is actually coming from chemistry. But since our embeddings are just being compared to similarity, and the similarity is based on token embeddings, it doesn't necessarily retrieve something with the best skills. Sometimes the best skills that we need to apply to solve our problem is not within our domain, right? So that's why we call for specialists also for other domains. And we'll do something as well here. So we catalog the skills in the repository, labeled one as the same skills, and then we will, and for that we use also LLMs. Then we cluster the skills to make sure that we are not too specific and not too generic. And, and this is example of cluster. For example, circuit geometry has this for example too. Then for each of the clusters, we will classify our examples, which skill was used the most. And when we will retrieve best example, instead of the RAG, we use our skill finder that actually finds you the task that use a similar skill. And so this is the whole whole method in a nutshell. But what is more important is how it works. If it's only useful if it works. And we found out that it's improving over the RAG and over the other methods for that. And this is a specific example. If you would use topic-based solution, you actually come up with a, let's say, wrong answer. Why we use positive solution, our solution, you get examples that make more sense, even if they're coming from a different domain. So we also find out that we can improve other domains. We also found out it improves coding. And it's not, I only talked about the math, but this is not a research. It also works for creative skills, biological skills, business strategy skills, and so on. And it still also makes with better alignment. For example, I want to get better networking at work. It thinks you're talking about internet if you go with chain of thought. But if it's about the skill base, it gives you answer that that you have. So I'm out of those times, so I will not go to other examples. I'll just finish on other work, advertising for other work, which was just presented in the AI Action Summit with Mike Jordan and our student Antoine and Eric Moulin. Thank you very much.
Ladies and gentlemen, hands together for Michael Valko. There we are.